Welcome to class, ladies and gentlemen. It is Thursday for you, I believe. Mr. Eicher here to talk about our next chapter, Conic Sections. We will take a quiz and do a test on Chapter 7 next week. Since I'm not around, rather than doing a quiz or test, let's learn basically one lesson on parabolas, which you've seen parabolas before. This is just from a slightly different angle. And then tomorrow we'll do some more practice with parabolas. So in this chapter, Chapter 8, talking about conic sections, these notes, you have pictures of the 4 different conic sections. You have an ellipse, a circle, a parabola, and a hyperbola. I found a little more colorful diagram online. So I want to explain why they're called conic sections. Conic sections. Conic sections. So a cone, if you have a cone on top of a cone, we might think of this right here as a cone, but if you put another cone on top, each cone is called a nape. If you take a plane, or like a piece of paper kind of looking thing right here, and you slice the cone at a certain angle, you could form a parabola. See that parabola right there? So this little parabola, kind of three-dimensional looking. If you slice a cone so that the plane is parallel to one of the bases of the cone, base down here, then you would get a circle. And if you slice the cone at a certain angle, you can form an ellipse. An ellipse is kind of elongated circle, which we'll talk about later in the chapter. And then the last one is a hyperbola. If you take a plane and slice both cones like this, then you would have a hyperbola which has 2 branches, one at the top and one at the bottom. So whenever we graph hyperbola, it will look kind of like this. It will have 2 branches, one on this side, one on this side. And that's because you're cutting the top and the bottom cone. So those are our four, count them, 4 conic sections that we'll talk about. In this lesson, we'll be focusing mainly on parabola. Next, I want to introduce you to some terms of a parabola that we haven't heard before. This is a website, mathwarehouse.com. Thank you. So the parabola you can see, maybe I'll highlight it right here, this parabola right here, so focus on that first. There's the parabola. There's 2 important points, or one's a point, one's a line. A parabola is the set of all points, so like this point is on the parabola. It is the set of all points that are the same distance away from a focus. The fixed point here is called the focus, so this distance is the exact same thing as this distance, the distance from the point in the parabola to a line, and that line is called the directrix. So every point on the parabola is the same distance away from the focus as it is the directrix. And you could keep going. You could take like this really far away point, however far that is, that point on the parabola is the same distance away from the focus as it is the directrix. So in our geometry days, we could say like these lines are congruent, little tick marks, 3 tick marks. So really the main new part of the lesson today is thinking in terms of a focus and thinking in terms of the directrix with parabolas. So let's fill out a couple of our notes and then we'll see what we're doing with this information. So a parabola is the set of all points, x, y, in a plane that are equidistant from a fixed line. That fixed line is the directrix, and a fixed point called the focus. In that point, the focus is not on the line. It's not on the parabola, and it's not on the directrix. So in our diagram here, this point is the focus, and this line here is the directrix. So the parabola is the set of all points. So like this point here is equidistant. This distance to the directrix is the exact same distance as it is to the focus. A term that you're familiar with is the vertex. The vertex is the midpoint between the focus and the directrix. So this point is the vertex of the parabola, right there. And it is equidistant. This is equal to that distance. Equidistant. The next one is a term that you're familiar with. The axis of symmetry. Axis of symmetry. This AOS, we'll call it, axis of symmetry, is this line that's perpendicular to the directrix, and it passes through the vertex and the focus. And probably the most important, other than all these terms, probably the most important component that we'll be using is 1 divided by 4a. 1 divided by 4a is the distance from the vertex to the focus. So over here in green, this amount is 1 over 4a. And likewise, the amount that the vertex is to the directrix, that is also 1 over 4a. And we'll be using that fact to write equations, or if we're given an equation, we'll use that to figure out where's the focus, where's the directrix. And then the last term, the line that passes through the focus and is parallel to the directrix. So let me get rid of this a little bit so we can focus on that. So the line that passes through the focus and is parallel to the directrix, this line we call the LR. LR. That stands for lattice rectus, or LR for short. So those are some important terms. We have 2 different standard forms that we use with parabolas. I like the one on the right because you're probably, you recognize that. This one right here, standard form. You'll notice we have 2. We have a y equals and we have an x equals. The y equals standard form are for parabolas that open up or down. Those would be functions. But the next one, the x equals, that would be for parabolas that open to the right if a is positive, or parabolas that open to the left if a is negative. So those aren't functions, but they are relations. They are conic sections. So that is a new part of the lesson today. This conic standard form with a given vertex, basically all that's happening is this 4p. If we divide both sides by 4p, we get 1 over 4p, which is basically equivalent to what a is in this one over here. So 1 over 4p equals r a. Solving for that, that would give us p equals, kind of rearrange things, gives us the 1 over 4a. I like to use this form on this side. Mr. Brack likes to use this form. But either form works, but whenever I answer things in this video, I'll be using the standard form on this side. Okay, so let's look at number 1. It says, quite simply, find the vertex, focus, directrix, and LR of the parabola given by y equals 1/8 x minus 2 squared plus 1. Let's start with the vertex. That's the fastest one. You should be familiar with the vertex. The vertex would be 2, 1, and we can graph that right here, 2, 1. Next, the focus is above the vertex by the amount 1 over 4a. So let's calculate what that equals. 1 over 4a would be 1 over 4 times, the a value is an eighth, that's a. So we'd have this. I'll be really careful with your multiplying here. That would be 1 over 4 times an eighth is a half, so that means we get a 2. So our focus is 2 above the vertex. So our focus is going to have the same x-coordinate, but the y-coordinate is going to be 2 above that. So we can kind of write it like that, but you can count it out. I'll do it in my blue marker here. It's 2 above the vertex, so that is the focus. And then our directrix is a line. So we need an equation of a line. It's a line that goes left-right. So that's a y equals line. Y equals, and the directrix is 1 over 4a below the vertex. So if the vertex is here at 2, 1, we could probably just immediately graph, go 2 down, and then this line is the directrix. And what's the equation of that line? Well, basically, we took the y-coordinate of the vertex and we subtracted 2. We went 2 down, so the equation is y equals -1. Make sure you write it as an equation. Don't just put -1, but do y equals -1. And then our focus, we have 2, 3. Okay, so we have focus, directrix, and lastly, we're asked to find the length of the LR. Now, there's a special formula for the LR that makes it really easy to get what the length is. But before I tell you, let's think about what the graph would look like. So we have, here's the focus, here's the directrix, and the vertex is that green dot. So the LR is going to be something that goes through the focus and it's parallel to the directrix. We just need to figure out what's the length of that line. So let's graph this. Remember, we have a 1/8. Typically, when we have a quadratic, we have x and x squared. You go 1 away from the vertex, 2 away from the vertex. Typically, you go 1 to the right, 1 up, 2 to the right, 4 up, squaring those. But we're going to multiply these by an eighth. So that would be, we would go right 1 up an eighth, which isn't very much. And then right 2 up a half, right 2 up a half. That's not very much either. Like right about there now. Let's go a couple more. Typically you go right 3 up 3 squared's 9, and then right 4 up 16. So let's go a couple more and see what happens. Multiply those by an eighth. So right 3 up 9/8. So right 3 up 9/8. A 9/8 would be a little bit more than 1. So right about there. And then we have 1 over, this should say 8, and that would be a 2. So right 4 up 2. And then we have symmetry on the other side, so we can kind of copy those points. Looks like right about there. Looks like that. So here's our parabola. what I'd like you to notice about the LR. The LR connects from here to here, and it passes through the focus. Notice that that's a perfect number here. It's not a fractional number. So this distance from here to here, that distance is 1, 2, 3, 4, 5, 6, 7, 8. How does that relate to our original equation? Well, our original equation had an A of 1 over 8. So the LR is simply the reciprocal of this 1 over 8. So the length of the LR, maybe we'll just write it up here, the LR length is the reciprocal of 1/8, which is just 8. So that's a pretty cool result. If you had, for instance, an A value of 1/4, if you had, for instance, A equals 1/4, then you could really quickly say, oh, the length of the LR is 4, and you're done. Alright, so I think we identified everything we needed to. Now let's work backwards on the next one, and this can be tricky, so make sure you're following along. If you need to pause the video and discuss with your neighbor, if you have a question, pause the video and ask, like, hey, where in the world the focus, or what's the directrix, or whatever. Alright, on this question you're asked, find the equation of the following parabola in standard form. We'll write it in this form. It's a parabola opening up, so it's a regular y equals a x minus h squared plus k. The vertex is probably the best place to start. The vertex here is at -1, -3, so we can immediately put in y equals a x minus a -1 squared minus 3. All we need now is the a value, and we have the equation. Well, notice there's two ways to think about this. Probably the fastest way is notice this line passing through the focus. This line is the LR. LR. Exclamation point. We're very excited about that. What is the length of the LR? Well, we could count. It's 3 on this side, and then it's 3 on this side. So it looks like the LR is 6. Remember what we said before, the LR is the reciprocal, so like 1 over A equals the LR length. So if the LR length is 6, we need the reciprocal of something to get 6, so the A must be 1/6. If we multiply both sides by A, that would put the A over here, and then divide both sides by 6, and you could see that that is now A equals 1/6. So we have our final equation. It's actually just that simple. We have y equals 1/6 x plus 1 squared minus 3, and that would be the equation of our parabola. There's another approach that you could take that some students like, so let me get rid of some of this drawing right here. Well, what's another way that you could find the a value? Well, this distance here, that distance is 1 over 4a. So 1 over 4a equals, that distance looks like it's 1.5. So, and then from there you can just solve for a. Multiply both sides by 4a, you get 1 equals 6a. And then divide both sides by 6, that would be 1/6 equals a. So that's another approach. You can use the length of the LR like we did the first step, this length, or you can use the fact that this distance is 1 over 4a. Let's look at number 3. Alright, so we have find the standard form of the equation of the parabola with a vertex of 3, -1, so we can graph 3, -1, there it is. And the focus is 3, 0, so that's the focus right there. State the equation of the directrix. So we need the equation of the parabola and the equation of the directrix. Well, the directrix is probably the fastest to do. Since the focus and vertex, that distance is 1, the directrix is the same distance away, just below the vertex. So here, this line would be the directrix. So the equation of that line would be y equals -2. So that part's all done. Now we just need the equation. We already have the vertex at this point, so we have y equals a x minus h squared plus k. That's our general standard form. And the vertex is, well, come on, brother. We already have the vertex. We have y equals a x minus 3 squared minus 1. All right, all we need is the a value. On this one, we don't know the length. We can't tell quickly what the length of the LR is, but we do know that this distance is equal to 1, which is the same as 1 over 4a. So if you have a 1 equals 1 over 4a, I hope you can see that it's pretty important to know this formula. You might want to highlight that 1 over 4a. It's going to be really helpful in these parabola questions. Solving this, multiply both sides by 4a, so you get 4a equals 1. So a is a quarter. So our final answer, we have the directrix equation here, and we have a y equals 1/4 times x minus 3 squared minus 1. And that's our answer. That's our equation of our parabola. Let's look at number 4. Number 4 is very similar to number 3 that we just did. It would be perfect as a try this. So if you'd like to pause the video, graph the information on the graph just to help yourself out, but ultimately you want the equation in standard form of the parabola. So pause this video and see if you can do that. The equation in standard form is in blue, y equals a x minus h squared plus k. I graph the points, the vertex v and the focus f. And then I also notice that the distance from the focus to the directrix is 4 units. So that 4 units is the same as our lovable formula 1 over 4a. Solving that, we would get 16a equals 1. So a is 1/16. I think at that point we can immediately write y equals, the a is 1/16. The x is x minus h, looking at the vertex coordinates, that's x minus 0 squared, and then plus 1. We can clean that up. Since x minus 0 is x, we have 1/16 x squared plus 1. That would be our equation of our parabola in standard form. Let's look at number 5. Alright, number 5, something changes. We have a parabola, but it's opening to the left. Notice the focus is to the left of the vertex. The focus is always captured inside the parabola. So here's the parabola going to, like, I want to catch you. It's chasing the focus. The focus is always inside. You'd never see a parabola with, like, here's the parabola and, like, the focus is, like, way out here. Like, what's going on? Something's wrong. But this one, we'd like to state the equation of the parabola. However, it's opening the wrong direction. It's opening to the left. So if we go back, the general form is different. It's not going to be y equals. So if we go back to this page on this side, notice this second one, x equals a times y minus k squared plus h. Notice the h and k flip-flop, and then the y and the x flip-flop. So we have to be careful when we have a parabola that's opening in that direction. So since it's opening to the left, we have x equals a, y minus k squared plus h. So really tricky here, so I'm going to label. So here's our vertex. Our vertex is 4, negative 2. 4 is the h, negative 2 is the k. Labeling those, when we go over here to write that, we get x equals a, y minus k. K is negative 2, so minus a negative is plus 2 squared. And then h is 4, and you just do a plus 4. So it does take a while. It's very easy to mix those up. So be careful to focus. Okay, well, anyway. So the next thing, we need the length of the LR and the equation of the directrix. Well, let's get the equation of the parabola first. This distance right there, that distance is a 2. That 2 equals 1 over 4a. So multiplying both sides, we would get 8a equals 1, so a is 1/8. So we can finish off the equation. It's x equals 1/8 y plus 2 squared plus 4. Box that thing up. What? There we go. Now the length of the LR is related to the a value. Do you remember what the formula for the LR is? If you don't, we can actually see the LR goes through the focus, and it is parallel. It goes through, that's a length of 4 so far, and that's another 4. So it's 8. Remember, it's the reciprocal of 1/8. So the LR equals 1 over a, which is 1 over 1/8. So the LR length is 8. And then lastly, the directrix is parallel to the LR. It's the same distance away that the vertex is to the focus. So this distance is 2, and the dashed directrix line would be the vertical line x equals 6, because there's the 6 right there. X equals 6. So we have our equation check, our LR check, and our equation of our directrix check. So that was an example where we have a parabola opening to the left. The trickiest part is you have a different formula, x equals a, y minus k squared plus h, anytime it's opening left or right. On to number 6. We're asked to find the vertex, focus, directrix, and LR of this equation. Well, what are we ever going to do? Is it an x equals or is it a y equals equation? We have x's and y's mixed up everywhere. What in the world's going on? Well, one thing to notice is you have a y squared and a y. We're going to have to collect those on one side. So how about we do that? That would give us 4x equals, so add y squared to both sides. We'll put it up in front, y squared plus 2y plus 13. Okay, so it looks like it's going to be a x equals, right? There's the x right here. It's going to be x equals some other stuff. But we want this expression to look kind of like y minus k squared plus h, and it doesn't look like that. We only want one y, that quantity squared. We don't want y squared plus a 2y. So what we're going to do is what's called completing the square, which we did a few months ago. So the way that I like to write it is, we'll just rewrite that 4x. I'm going to write the y squared plus 2y, whoops, needed 2 in there, 2y, plus blank, plus 13. The 13 is kind of in my way, so I just want to shift it over a little bit. And to complete the square, we're going to take this number, which we call the b, we're going to divide by 2, and we're going to square it. And that'll tell us what to put in this spot right here. So we can form a perfect square trinomial, so that when we factor it, it'll look like that, y minus k squared. So what number do we want? We want 2 over 2 squared. That would be a 1. We need to add 1 to the left and to the right side. Make sure you add it to the left side as well as the right side. Okay, so this is what we have so far. We have 1 plus 4x equals. We want to factor that trinomial. Factoring that would be y plus 1 squared, and then plus 13. Okay, so let's solve for x now. It's an x equals type of parabola. So we want to subtract 1 from both sides. 4x equals y plus 1 squared. Minus 1 from both sides, that would be a plus 12 now. And then we'll divide by 4. So we have x equals, dividing by 4 is multiplying by a fourth, same thing, 1/4, y plus 1 squared. Then 12 over 4 is a 3. So here's our equation of our parabola. It's a parabola that's opening left or right. You can tell which direction that if the A is positive, then the parabola will be opening that way. Which made me realize I need to go back to number 5. So let's just finish this first. Okay, so we have our equation. We need to find the vertex. Well, this is H and this is K. So the vertex would be a 3, comma, a negative 1. So 3, negative 1. Next, the focus is going to be inside the parabola. So it's going to be to the right, if you see that down there. It's going to be to the right of the vertex. So remember our formula, 1 over 4a, where the a is a fourth. So that would be 1 over 1. So the focus is 1 unit to the right. And that means the directrix is 1 unit to the left. And the directrix is an equation of a line. So we can just identify the focus is here. The focus is at 4, negative 1. The directrix is here. Directrix is the x equals line, x equals 2. The vertex we have listed right here. And then lastly our LR. Our LR is the reciprocal. The LR is the reciprocal of this, so the LR is 4. So the LR would be, you can use it to help yourself graph, the LR would be 2 up and then 2 down. So the parabola is going to look like this. One helpful use of the LR is making a quick sketch like that. So that's our equation. I wanted to go back and look at number 5, because number 5 we had a parabola opening to the left. So the equation that we had, let's see if I can remember this. This was 4, negative 2. The equation we had was x equals, the a was an eighth, and that would be y minus k, so we had a plus 2 squared, and then a plus 4. That was the equation we had, right? The problem with our equation is since this is opening to the left, our a value must be negative. It must be less than 0. So just like a parabola opening down has an a value that's negative, likewise if it's opening to the left, our a value should be negative. So we should have had a negative 1/8 right there. So that's something you have to be careful about that I admit I wasn't very careful about when I was doing that problem. We have 2 more, number 7 and 8, so let's look at those. This question, we're not given a grid to help ourselves out, and we're given an equation that's not closely in the standard form, but we're asked to find the vertex, focus, directrix, axis of symmetry, and LR. So the whole kit and caboodle. So notice on this one, we have a solitary x, just all by itself, x. This tells us that the equation we need to write is x equals a y minus k squared plus h. So in this example, we would like to complete the square so that the left side looks like this, a binomial squared. So again, the way that I like to set it up, we get a y squared plus 4y plus blank plus 10 equals 2x, and then we'll even do a plus blank on this side so we don't forget to add the same amount on both sides. So to complete the square, we're going to take this 4, we're going to do 4 over 2 and then square it. That would be 2 squared, so 4 and 4. Okay, now we can factor this guy right there. We can factor that to be y plus 2 squared plus 10 equals 2x plus 4. Okay, so now let's move everything from the right side to the left side. Get x all by his lonesome. Subtract 4 from both sides, so that gives us this. Plus 6 equals 2x. And then divide both terms by 2. The first term will just be a 1/2, y plus 2 squared. And then 6 divided by 2 is 3. So here is our standard form. Let's see if we can list everything. Our vertex would be hk in that order. So our vertex would be h comma k, that would be 3, comma, the opposite of that, so 3 comma negative 2. Our focus, to be able to figure out the focus and directrix, we're going to need the quantity, what is 1 over 4a? That would be 1 over 4 times a half. So that would be 4 times a half is 2. So 1 over 2. So the focus, this is a parabola opening to the right because we have an x, so it's not up or down, it's left or right, and it's a positive a value. So it opens this way, and the focus is right in the middle, and the directrix is out here somewhere. So the focus is, take the coordinates of the vertex, here's the focus, it's going to be 1/2 to the right of the vertex. So you're going to add the 1/2 to the x coordinate, excuse me, and the y coordinate stays the same. The directrix, you're going to subtract the 1/2, this 1/2 right here, subtract that from the vertex, the x coordinate, so that would be the line x equals 2.5. The axis of symmetry is the dashed line that goes through the focus and the vertex. So the axis of symmetry is y equals -2. And the LR, my favorite, because it's so fast. What's my a value? There's my a value. What's the reciprocal of that? 2. So there is all the information that we were looking for, having to complete the square first to be able to identify that. Also, just want to point out once again how important this formula is. Oh, that didn't work very well. How important this formula is, try again. There we go. How important that formula is to figure out where the focus and directrix are. Alright, we have one more. So let's check out number 8. On number 8, notice we have an x squared and a 10x. We're going to complete the square on that side, and y is all by its lonesome. So let's move y to the other side. So we would have x squared minus 10x plus blank plus 7 equals, add 6y to both sides, and then plus blank. I'd like you to pause the video to see if you're able to complete the square correctly. See if you can complete the square and write the equation in standard form. Don't list all the other stuff first, just see if you could do that. So I hope you chose 10 over 2 squared as 25. Hope you added 25 to both sides. Hope you factored right, x minus 5 squared. We'd like to get y all by itself. So we're going to subtract 25 from both sides. So we get x minus 5 squared minus 25 from that's negative 18 equals 6y. And then we're going to divide both sides by 6. That'll give us a 1/6 x minus 5 squared. And 18 divided by 6 is minus 3. So there's our equation. See if we can write all the stuff that they're asking us for. The vertex. The vertex is just 5, negative 3. And remember, we need our very, very friendly, famous 1 over 4a. We need that to be able to determine the focus and directrix. So 1 over 4a, we have 1 over 4 times 1/6, which is 1 over 4/6. The reciprocal of that is 6/4. So that looks like it's going to be a 3/2. So the amount that we go from the vertex to the focus is 3/2, or 1.5. Same thing. It's really helpful for me. I know the parabola is opening up. It's a y equals. It's a regular old parabola. And it's a positive a value, so it's opening up. So the focus is above the vertex. The directrix is below the vertex. So we need to go 1.5 above the vertex. So if the vertex coordinates were 5 and then the negative 3, it's going to go up, so plus 1.5. So our focus, coordinates of our focus would be 5, negative 1.5. Our directrix would be the y equals line down here, and the vertex was at negative 3, so you're going to go down, so that would be a negative 4.5. So it's y equals negative 4.5. And we have two last things to identify. The axis of symmetry is this vertical line. So the axis of symmetry is an x equals line. It's vertical, so it's x equals. And it passes through the vertex, and the vertex has a 5, so it's x equals 5. And then finally, I think that's it. The LR is the reciprocal of 1 over 6, so the LR is 6. So let's bring this all together. We have our equation right here. We have our vertex right here. We have our focus. We have our directrix. We have our axis of symmetry. And we have our LR length of 6. Thank you for watching the video, and good luck on the homework. Parabolas can take a lot of time to get used to, especially with this focus and directrix new idea. So have patience, get your practice, ask questions, ask your neighbor, ask the in-class tutors, and yeah, good luck, more practice, you'll be able to get this down. Thanks for watching, see you next time.